Chapter number 9, chemical equilibrium, is based on the rate of the forward reaction is equal to the rate of the reverse reaction. Main objectives: student will be able to define chemical equilibrium in terms of a reversible reaction, write both the forward and reverse reactions. First of all, introduction. Generally, we presume that most chemical and physical changes proceed to completion. A complete reaction is one in which all reactants are converted into a product. Most chemical reactions do not go to completion because products react themselves to form the reactants. Many examples of the physical and chemical equilibrium are found in nature. We owe existence to equilibrium phenomena taking place in atmosphere. We inhale oxygen and exhale carbon dioxide, while plants consume carbon dioxide and release oxygen. This natural process is responsible for the existence of life on the earth. Reactants and products. Substances that combine is called reactants. New substances are formed after combination is called the product. For example, hydrogen gas plus oxygen gas react together to form a water molecule. It means hydrogen and oxygen is a reactants, and after combination they form a new product. New substance is called the product in the presence of a catalyst and the atmospheric effects, temperature, pressure, heat. Reversible and irreversible reactions. Reversible reaction: products do not recombine to form reactants, putting a single arrow. Reversible reaction: products can recombine to form a reactants, putting a double arrow. For example, in a irreversible reaction, the reactants combine to form a product. The products not converted into a reactants. But in a reversible reaction, reactant combine to form a product and product recombine to form a reactant. Reversible reaction explanation. Both direction, forward as well as backward, never goes to completion. This reaction is never goes to completion. For example, H2 and I2 is converted into 2HI and 2HI is converted into hydrogen and iodine. Consider formation of hydrogen iodide. Okay. Let us discuss a reaction between hydrogen and iodine, because one of the reactant is purple, iodine. Well, the product hydrogen iodide is a colorless. Hydrogen is a colorless and iodine is in a purple color. When heat, they combine to form a hydrogen iodide. There is a colorless. On heating hydrogen and iodine vapor in a closed flask, hydrogen iodide is formed. As a result, purple color of the iodine is fade, as it reacts to form a colorless hydrogen iodide. H2 and I2 is converted into 2HI. This reaction is called the forward reaction. In a reverse reaction or the backward reaction, they are also called as a backward reaction. On the other hand, when only hydrogen iodide is heated in a closed flask, purple color of the appears because of the formation of iodine vapors, such as 2HI is heated, they are converted into H2 and I2. In this case, hydrogen iodide acts as a reactant and produces hydrogen and iodine vapors. This reaction is reverse of the above. Therefore, It is called a reversible reaction. When both of the reaction written together as a reversible reaction, these are represented as hydrogen iodide, hydrogen gas and iodine gas are react together in a closed flask. Purple color is fade and they form a hydrogen iodide is a colorless. When hydrogen iodide is react in is heated in a closed flask, they are converted into hydrogen gas and iodine gas, and purple color is reappeared. So the next example is calcium oxide and carbon dioxide. They form a calcium carbonate. Home task. What are irreversible reactions? What are reversible reactions? Define in reactants and products. Explain establishment of the irreversible reaction through experiment. Experiment. In this experiment, you write the calcium oxide and carbon dioxide. They form a calcium carbonate.